So what's actually driving the need for resolution improvements is really that chain diagnosis is used during new product introduction and during yield ramp, where time is of the essence. Taking a longer time to sort out a systematic issue might end up missing the time to market at all for the whole product. So the essence of it is, as you improve resolution, you kind of sort out more, you can find more systematic defects that are occurring and root them out more quickly. In the Tessent organization, we've introduced 3 new pieces of technology: layer-aware chain diagnosis, cell-aware chain diagnosis, and global control signal diagnosis. All these 3 pieces have been known to cause the resolution to blow up, and we've targeted each of them separately. For example, layer-aware chain diagnosis targets interconnect defects. So it allows us as a tool vendor to isolate defects that are happening only in the interconnect between 2 different scan cells. Cell-aware chain diagnosis allows us to go inside of the cell and tell you exactly at the transistor level where something might be failing, where the defect is in the shift path. And global control signal diagnosis allows us to really find global control signals that are causing catastrophic fails on the device. Things like scan enable, clocks, sets, and resets. So the impact of yield on the chiplet economy is huge. In the chiplet economy, each chiplet is its own separate design. Improving the yield of every single chiplet is of tantamount importance to the overall device that you're going to ship. So if you have a lower yielding product or chiplet, bringing it all together and harvesting the pieces that are good and rooting out the bad parts and the systematic issues is of real importance, because you want to be able to meet that time to market window. What have customers seen with this new high-resolution chain diagnosis technology? Basically, what we've seen in a high-volume chain diagnosis study on actual silicon, we've seen about an 80% improvement in the amount of resolution. That is, the area in which failure analysis needs to look has been greatly reduced by about 80% on average across over 1,000 failing die. In retrospect, scan diagnosis and especially chain diagnosis are going to be a crucial factor, especially in the age of backside power, where certain optical fault isolation tools are going to be very limited or even deprecated. So the reliance on design is going to play into a very big part of yield and getting to that time to market.